Well, if you've hung in there this far, you've done a lot. And we are coming to the second to the last of the strategies that we're going to tackle in this course. So this strategy is going to be one where we take equations that have multiple trig functions and are not factorable, and we do a little bit of math magic. So let's jump in and I'll show you what I mean. Before we do this, we need to remind ourselves what are the fundamental trig identities, okay, because we are going to use them to transform equations that don't line up the way that we think that they should. So let's review. The Pythagorean identities. The big Pythagorean identity is sine squared of x plus cosine squared of x is equal to 1. And then from this one, we can derive these other two. Tangent squared of x plus 1 is equal to secant squared of x, and 1 plus cotangent squared of x is equal to cosecant squared of x. Jot these down on the side of your notes just so you have them handy. Keep this in mind. If an equation has more than one trig function and it doesn't factor, try using an identity. So here's our steps. First thing, we're going to make a substitution from an identity so that the equation has only one trig function in it. Second, we'll simplify the resulting equation. And third, we'll use the previous strategies that we've talked about to isolate the trig function and solve for the variable. And then finally, we will solve for the variable. Let's give this a shot. Our first example is this equation. 2 times the sine squared of x minus 3 cosine of x is equal to 0. I notice right away that I have a sine function and a cosine function. I really want there to be only one trig function within the equation. So I'm going to think about those Pythagorean identities. Okay, remember that sine squared of x plus cosine squared of x is equal to 1? Well, this means that if I move this cosine squared of x to the other side, I get that sine squared of x is equal to 1 minus cosine squared of x. If I substitute this whole expression into this equation where the sine squared of x is, then you will notice that the sine function will no longer be part of the equation, and the entire equation would be written in the function cosine. So let's do that. Let's replace sine squared of x with 1 minus cosine squared of x. Okay. So now if I look at this equation, the only function I see is cosine, and that's good. This will allow me to solve the equation. So let's clean it up a little bit. Let's take and distribute the 2 through to both terms here. I would end up with 2 minus 2 cosine squared of x minus 3 cosine of x is equal to 0. All right, looks good. And it kind of looks like it might be quadratic, right? This is telling me it looks like it's a quadratic function. So let's go ahead and put it in standard form with a cosine squared term in the front. And let's make it positive as well. So think about it as shifting everything to the right-hand side. That's one way to think about it. Another way to think about it is rearranging the terms and multiplying it all by -1. Either way, you should get a result of 2 cosine squared of x plus 3 cosine of x minus 2 is equal to 0. Now I can treat this like a quadratic. I can make a u substitution and say, let's say that u is equal to cosine of x. That would mean that this function would now look like 2u squared plus 3u minus 2 is equal to 0. I can factor it, and then I can back substitute what I took out. I took the cosine of x out and made it u, so let's put it back in wherever I see u. Oh, I see you. That's a funny pun. All right, and then I am able to set each of these factors equal to 0 and solve for x. So 2 cosine of x minus 1 is equal to 0, and cosine of x plus 2 is equal to 0. Let's isolate the trig function. So for this first factor, I would add 1 and divide by 2. And for the second factor, I would just subtract the 2. So I would end up with cosine of x is equal to 1/2 and cosine of x is equal to -2. All right, so now let's solve each of these equations and see what our outputs are going to be. So cosine of x is equal to 1/2. This is saying where on the unit circle are my x coordinates 1/2. That's going to happen on the right side of the unit circle at pi/3 and 5pi/3. And now here, cosine of x is equal to -2. We have a problem there, right? Because remember, the cosine function has a range of -1 to +1. So there's nowhere that I'm going to have an output that is equal to -2. All right, that's out of range. Okay, and so this ends up being our entire solution set, pi/3 and 5pi/3. All right, let's try another example. Oh, this looks very similar. And in fact, it is pretty much the same thing. Let's see how you do walking through this with me. All right, I have 2 cosine squared of x minus sine of x equals 1. Okay, notice I'm in sine and cosine here, but I have a cosine squared function here. So I'm going to think about using a Pythagorean identity to get rid of this. Okay, so same idea. Sine squared of x plus cosine squared of x is equal to 1. That means if I move this sine squared of x to the right-hand side, I'd have the cosine squared of x is equal to 1 minus sine squared of x. Okay, so let's think about placing this resulting expression, 1 minus sine squared of x, in this equation where I see cosine squared of x. Okay. Looks good. Now let's simplify. Let's distribute the 2 through. So I'd have 2 minus 2 sine squared of x minus sine of x is equal to 1. Let's rearrange the terms so that our highest power is in front and it's positive. Okay, so let's go ahead and think about it as taking everything to the right-hand side. We would have a positive 2 sine squared of x, a positive sine of x, and then I would subtract this 2 from the other side. All right, so I have 2 sine squared of x plus sine of x minus 1 is equal to 0. Another quadratic function. Go ahead and think about u being sine of x. All right. Now, if I know that u is sine of x, I can rewrite this and treat it like that resulting quadratic. 2 times u squared plus u minus 1 is equal to 0. Great. Now we think about how would that factor. We're going to factor this as 2u minus 1 times u plus 1 is equal to 0. Okay, so now go ahead and back substitute this sine of x into these expressions where you see u. So 2 times the sine of x minus 1 times sine of x plus 1 is equal to 0. Beautiful. All right, so now I think we're ready to actually solve for x. Take each of those factors and set them equal to 0. So 2 times the sine of x minus 1 equals 0. And sine of x plus 1 is equal to 0. Isolate the trig function, so get this sine of x by itself here by adding 1 and dividing by 2, and get this sine of x by itself by subtracting 1. All right, now we're trying to think about where are these equations true on the unit circle. Where is the sine of x equal to 1/2? Which angles have a y coordinate of 1/2? You'll find those on the top half of the unit circle at pi/6 and 5pi/6. And then sine of x is equal to -1 where? That's directly on the y-axis straight down at 3pi/2. And those 3 angle measures would be our solution set for this equation. Last example. And now you kind of know the drill. Can you tell me, without even looking, what we would do here? We would take that sine squared of x and replace it with 1 minus cosine squared of x. All right, so let's do that. Let's replace it there. So we have 4 times 1 minus cosine squared of x plus 4 times the cosine of x is equal to 5. Great. Distribute that 4 through. So 4 minus 4 cosine squared of x plus 4 cosine of x is equal to 5. Excellent. Rearrange things so that our cosine squared term is in the front. So let's shift this to the right, shift this to the right, and shift this to the right. We would end up with 4 cosine squared of x minus 4 cosine of x plus 1 is equal to 0. All right, treat it like a quadratic. Replace those cosines of x with u. And we would end up with 4u squared minus 4u plus 1 is equal to 0. I think that factors as 2u minus 1 times 2u minus 1, also known as 2u minus 1 quantity squared. Replace the u with cosine of x, and then we're ready to solve. Take each factor, and they're the same factor, so you only really need to do it once. Set it equal to 0. 2 cosine of x minus 1 is equal to 0. Add 1, divide by 2. Cosine of x is equal to 1/2. And I think that we just did that, right? Where does that happen? I believe that's on the right side of the unit circle at pi over 3 and 5 pi over 3. And that's all there is to this type of problem. Keep those Pythagorean identities handy, and they should provide you the support that you need to revise these equations and do a little math magic of your own. See you next time.